the first one that we're going to do is taking it back to quadratics, so our U shapes. So remember when we did our house where there was a naughty kid, a trampoline kid, okay? So when we're doing it, we have our normal vertex form for a quadratic equation. Does anyone remember what the plus or minus on the back end of that k value does? Up or down, my trampoline kid? Yes. Oh, okay, come back up here. It should be that one, yep. What did I give you? Oh, lucky you. Okay. Anyone remember? Did I give you one too? Oh. Anyone remember what the H does? That's the naughty kid on the inside. Okay, that's my left, right. Remember, it's always the opposite direction that you think it's going to go. So if it's a minus, it actually goes right. Okay. And then we're going to go to the last ones, which are the hardest ones. What happens when I throw a number in front? Does that move it up? We have a reflection. We have a reflect across the x-axis. Remember, keep your ex-girlfriend, ex-boyfriend outside. Okay, which means reflect y-axis would be on the inside. You reflected on why you dated them. Okay, what if I throw a 2 in front? If I multiply something times 2, what's it going to do? If I multiply something times 2, what's it going to do? Double it, yes, get bigger. Opposite of compress. No. Well, okay, so we have compression, but if I multiply times 2, what's the opposite of compress? Stretch, expands, get bigger, right? So we have our stretch and we have our compress. Okay, that's also going to be that A value. Just remember the negatives do something different. So if you have a negative in the front, that's a reflection, and then the number means stretch or compress. Okay, so the reason I compared it to our quadratics is because our quadratics are going to work the exact same as our square roots, absolute values, linears, okay? They all kind of work the same in where things are moving. So first we're just going to kind of intro it, and then we're going to put it all into one like we just did with our quadratics. So first thing I want you guys to do is graph the square root of x in your graphic calculators, which I'll get mine up here. Graph the square root of x. Second, x squared, square root of x. It should look like our shooting star once I resume here. So remember, if you need to resume, press zoom, and then your number 6. So there's my shooting star. Okay, if you want to look at your table values to get your points, you press second graph, and we're going to graph some of those table values. Why do I have errors? Well, why can't I go there? Why can't I use -3, -4, -5? Why? If I look at the equation, if I look at this equation, can I plug negatives in underneath the first square root of x? I can't just plug square root of -6, square root of -5, square root of -4. It would give me an error in my calculator. Okay, so we can't start negatives, which is why there's kind of like what is an imaginary. There's not a full asymptote there, but there's like a wall that we're not going to be going across, guys. Okay, so we're going to graph some of the points. So my first point should be at 0, 0. Okay, my next one, I got 1, 1. I'm going to pick the next pretty point. So my next pretty point is going to be 4, 2, and just kind of connect them to get that shooting star. Okay, there was the shortcut 1, 3, 5. So up 1, right 1, up 1, right 3, up 1, right 5. I know some of you didn't like the shortcut last time, so that's why I just went off the table. All right, so the next one we're going to type in is with +2. We're going to see what it does. Ooh, today would be helpful if you had different colored pencils. So if you want, work. Here are some colored pencils if you guys want them. Because I'm going to switch colors, so it's going to be helpful if you guys do too. Otherwise, if you have 3 different colors, it's going to be a little. I think we're doing the max of 3 on each, so just have, well, you have your pencils, and just 2 other colors. Okay, so the first thing that we grabbed was the parent. Remember, the parent is the OG before we moved it. So what we're actually going to do is we're going to graph this on all 4 of them, so we have our parent function on all 4. Okay, so I'm also going to put the same thing right here. So 0, 0, up 1, right 1. And then we have 1, 2, 3, 4, 2. And notice I'm just labeling them M of X because that was his parent function name. And we're going to put the parent on all of these. So that then we can tell. So it's up 1, right 1, up 1, right 3. The next one would be up 1, right 5. But so go ahead and get those parents on there. And then we'll actually do the next one. When you're done, can you put your pencil down so that I could tell that I can start graphing the next one? I think all finishing up. So we're going to graph the square root of x plus 2. So notice that the plus 2 is underneath the square root. So make sure when you type it in, we've got our second square root of x plus 2. If you get prompted with parentheses, so I think potentially the 83s or the late 84s, if you get a parenthesis, make sure you end the parenthesis after the plus 2 to make sure that the plus 2 is on the inside. Anyone want to take a guess as to what direction it's going to send it? Left? Yeah. Okay, you went left too. So we're going to regraph it. So everyone go ahead and look at your table. So press second graph. I'm going to do negative 2, 0. So there's my negative 2, 0. And my next pretty one is negative 1, 1. So I'm going to go left 1, up 1. Remember when you do points, you go left or right, you walk the elevator, then you ride the elevator. Negative 1, 1. What's our next pretty one? 2, 2. So right 2, up 2. And then we're going to label this P of X. And go ahead and shove a little left up there so that we know that's the direction it's in. Right 2, up 2. So are you doing the shortcut or are you doing it just based on points? Points 2, 2. All right, you guys want to try to take a stab at what minus 3 is going to do? Plus 2 is plus. What's the opposite? It's going to go right. I'm going to change colors here. Okay, Okay, so I got a minus 3 going in. Okay, we got our right 3. So I'm going to look at my table so I can actually get some things in here. Okay, so I've got 3, 0 for my first one. So I'm going to go 3, 0. I've got 4, 1. So I'm going to go right 4, up 1. The next pretty one here is 7, 2. 7. Label pen. Okay, so on the inside of our square root, just like the inside quadratics, we have our lefts and rights. It's the opposite direction of what you think, so the opposite kind of that sign again. Put your pencil down once you're done, because I'm going to ask you guys a question, but I want to make sure. Gotta get back to our face nice. I'm going to ask questions. So the very first one, I said I couldn't have any negative answers. Why is it in this one I can have -2 and -1? If I was doing my domain in this, my domain would be from -2 to infinity. My apologies, because we're doing our x values for domain. Why can I include the -2 and the -1 in this one, where in the original I couldn't have those? Why can I have -2 and -1? So the equation I typed in was this one, square root of x plus 2. Why does -2 and -1 work for domain? Because this was a question on the test. Why does -2 and -1 work for that domain? Okay, domain my x's or my y's. Okay, domain is my x's. So, if I plug -2 in for my x, so if I plug -2 in here, what's -2 plus 2? Can I square root 0? Yeah. Let's take -1. What's -1 plus 2? Can I square root 1? Yeah, we can. So, is there a possibility of having negative answers for my domain or for my x values? There is. I had 99% of you on the test when I asked the question about a square root function, did I ever have negative values for my domain? You said no, because you said I cannot have negatives under my square root, which is true. But if I have plus something in here, and it's plus a big enough number, I can have negative x values because it's shifted over far. Okay. Okay, let's see what plus 2 and -3 on the outside are going to do. Anyone got an idea of what a plus 2 and a -3 are going to do on the outside? Up or down, and that one's going to be our normal. So this one's going to end up going up. This one's going to end up taking it down. So just make sure that plus 2 is either outside of your parentheses if you get parentheses for parentheses. So if you get a parentheses, end your parentheses after the x and do plus 2 or -3. If you don't, just make sure you use your over arrow to do your plus 2. So if you're struggling with it, you can follow me. So there's my square root of x. I'm pressing over to get out of it. I'm going to do my plus 2 first so I can see it shift up 2. Then I'm going to look at my table values. Okay, so this would not change my domain at all. It would only change my range. Because my range is my y values, and I shifted it up on the y-axis. Second table. If you just give me some general sketch, it's going to be wrong. I need some actual physical points. Okay? So my first one I'm going to do is 0, 2. Don't go left to right, I go up 2, so there's my 0, 2. And I go 1, 3. Right one, up 3. And then 4, 4. This is my p of x. I'm going to get my down 3 going. Hopefully I won't dump you guys. Right, so we've had our lefts, rights, our ups, downs. It's the same as quadratics. Lefts and rights are on the inside, ups and downs are on the outside. Trampoline kid, naughty kid. Go in the opposite direction. The next two are the hardest ones. You guys ready for me to go to the next two, or are we still? No, okay, we're still in the last one. Ready to go? All right. You guys remember what doing a number in the front does for our quadratics? When I multiply something times 2, negatives reflect. Stretch and compress. Something number bigger than 1. If I multiply something times 2, I get bigger. I double, right? So my points are going to stretch out. It looks a little bit weird on square roots. Okay, whereas when we did quadratics, you can see it get fatter. Square roots are going to do a little bit different. Okay, but the points will stretch out. Whereas compressed, between 0 and 1, the points are going to get closer together, compressing towards each other. First, we're going to do that too. So we're going to do 2. If you want to do the time sign, I think it lets you do it. Otherwise, you can just put the 2 right there. I know some people like to have the actual time sign. Okay, it looks very similar to the OG. Okay, but when we actually go to graph the points, you're going to see it stretch out. It does actually get a little bit higher than our original when it stretches out. So let's go ahead and look at its table. Okay, so the first one I'm going to graph is 0, 0. Can someone tell me my next point so I don't have to keep flipping back and forth? 1, 2. Okay, and what's the next one? Next pretty one. 4, 4. So my original, the first 2 points are right here. My next 2 points are further out. Okay, this one to the next one is here. This is further out. My next one would be here. He's further out. So you can see how the points are stretching out. He does get a little bit taller. Whereas when I compress it, it will flatten out a little more. So we're going to do our 1/4. What decimal is that? In case someone uses decimal. 0.25 for those of you that like to go the decimal route a little bit more. Okay, otherwise, what I'm going to do, if you want to use a fraction, just to be safe, we practice putting them in parentheses last topic. Just put them in parentheses again in case you get something. Okay, so I've got my 1/4 square root of x, or you can just use your decimal. Notice he did flatten, so when he compresses, the points will get closer together. Flatten out a little bit more. Okay, looking at the table, I got 0, 0 to start it, and then I'm going to have someone tell me points again. What's another pretty point? These ones are going to be bad. Is there another pretty point? Okay, so let's try to get 1 and then 0.5. So write 1 fairly above it. I'm going to do 1 a little bit further down because if I do, well, I can do 4 of that. So I'm going to go, right, 1, 2, 3, 4. It should be a little bit higher than my other green dot. Okay, notice the points went from my blue dot, the spread part, to really close together. You can see it compressing, all those points close together. Okay, so this one is our stretch, because we multiplied times 2. And our compressed because it is between 0 and 1. Remember, negatives do something different. If I throw a negative with a number, the negative is going to do a reflection. Yep. So we're going to see our reflections happening here. Anyone remember a negative's on the outside of a quadratic? And it's the x-axis or y-axis if it's on the outside? Huh? X-axis. Keep your x outside, right? So this should reflect across the x. And this should reflect across the y. Okay? Don't use the minus sign. Otherwise, your calculator will probably tell you error. You have to use the negative sign. Okay? So I'm going to get my negative square root of x in here. It's them reflecting down. It should just be a mirror table. So I should have the exact same thing, but it will mirror downward. And then when I reflect across my y-axis, this blue line will flip across this way. So he'll be shooting out this way. In which case, a lot of negative answers are going to be working for my domain. Actually, all negative answers will work for that domain. Because when I send a negative in for a negative x, it will force him to become a positive. So when you go to type the next one in, it should be a flip this way. So he's got a lot of negative answers that will work. So when you're done, I want you guys to try to fill out what each of the parts mean again. So does H mean left, right, up, down, stretch, compress, reflect X, reflect Y? What does K mean? Or what A means? That A means is it stretch, compress, left, right, up, down, reflect X, reflect Y? So all of your options are stretch, compress, reflect X, reflect Y, left, right, up, down. Those used in our general OG transformation function here. Then we're going to make some equations and then talk about exponentials. Which exponentials you guys got in I9? I am 10. Huh? It's going to be the exact. I'm trying to show you that quadratics do the exact same thing as square root. Sure notes, Andrew. All right, what's the plus K value do? Up, down, trampoline kid. The H on the inside. Okay, if the negative is on the inside, does it reflect X or reflect Y? Reflect them like graded them. Okay, which means reflect X is out here. What else is that A value? Stretch, compress. There's one more thing that I want to talk about, and it's the H and the K. So the H and the K of our original was our vertex. So when we looked at the quadratic, this H and this K stood for our vertex. Remember, anytime we pulled the H out, we had to flip it because it's coming out of the parentheses. It is the exact same for quadratics. So this vertex here, if I took this guy out, he would become a -2. What k values out here that we don't see? What number can we not see? 0. So that tells me my shooting star starts at -2, 0, which is right here. Okay, this shooting star, if I flip him, he would be at 3, 0. That's why his shooting star starts at 0. Okay, what number sits in here with this x? What would be the h value that sits in with this x, guys? 0, and his k value is 2, which means his shooting star will start at 0, 2. Right here. What would this one be? What h value sits on the inside? 0, -3. Okay, so his shooting star should start at 0, -3. This is the one a lot of people mess up. What h value sits on the inside with the x? 0. What's the k value on the outside? 0, 0. So all of these shooting stars start at 0, 0. A lot of you guys think that 2 is the x value, the h. Okay, but it's what is adding or subtracting on the inside with the x? Nothing. What's adding and subtracting on the outside? Nothing. So then his would be 0, 0. Same with this. There is no h value, there is no k value, which is why those shooting stars started at 0, 0. Okay, so that's like your x, your y, we like to call it our vertex, okay, or where our shooting star starts. That little guy right there. So once you have that, if you're writing it, flip to the next page, we're going to make some equations. All right, make an equation that shifts left 3 up 9 and reflects across the x-axis through our parent function y is equal to square root of x. All right, so what part in it do you guys want to put in first? The left, the up, or the reflect? The reflect, so if it's the x-axis, it's going to be on the outside or the inside? Outside. Okay, so that was my reflect x-axis. Would you guys like to do the left 3 or up 9 next? Left 3 or up 9? Okay, so is that going to be on the inside or the outside from the top? Inside, is it a +3 or a -3? It's opposite. We're doing it +3. So my left 3, we've got the negative still. Now we're adding that +3 in. Now if I'm doing my up 9, it's going to be on the outside. Is it a +9 or a -9? So that is my final answer. Y to the 9. Oh, when we're finding inverses. Inverses, we're not doing inverses. Okay? So the next one, I want you guys to try and help. There's a one that says dilates, but dilating by a factor of 2, what is dilating do? Makes it bigger. What word are we going to use though from our options? Stretch. So we're going to stretch by 2. So try to shove everything in where you can be able to the next one. getting what O's do. So we're going to put that 2 in the front with our reflection. And then okay, the right 2 is at -2 or +2. Down 7, we should have -7. Is my dilate of the 2. So the next one, we're going to make equations based on our, let's do this real quick. Let's do our vertex. So where does the shooting star start? I want to know where the shooting star would start. So if I pull out the H and the K, so when I take this 3 out, what would he become? +3 or -3? Okay, just like when we were in parentheses taking something out, it flips. When I come out of the square root, it's the same. So his vertex would be at -3. What would his K value be? So his shooting star would start at -3, 9. Where would the next shooting star start? +2. This guy, -7. The stretching, compressing do not change your vertex at all. All right, my next couple pictures, I don't think I gave you a stretch or compress on any of them. We're just going to do some like more basic making equations. So, what direction did I move my picture from? So if it only starts at 0, 0, what directions did it move? Left how many? Okay, so if my OG is this, shove the left 5 into it. Okay, you should have gotten y equals square root of x plus 5. Plus 5 should be on the inside. If you look at the vertex, so if I pull this vertex back out, you would be -5, 0, which, guys, is exactly where that vertex is. So you don't even have to know what direction it moves. If you find the vertex, you can actually shove that vertex value in, and it will give you your answers. Okay? So I want you guys to try the next 3. We have 10 minutes here. Try the next 3. Okay, let's do it. I can see. 0. So this one's right 2. Okay, or his vertex is at 2, 0. So it should be like this. Okay, this one we went up 3. Okay, or I could say his vertex is at 0, 3. So when I plug it in, there is nothing in there for the h value. The k value is a positive 3. Okay, the next one we went right 1. And we reflected. Did we reflect across the x-axis or y-axis? Okay, so I know there's a negative in the front. Then I can use the vertex point, which is 1, 0. Okay, so go ahead and check your answers and we'll move to your question. I'm moving on to exponentials to kind of see what they look like. So remember when we were doing radicals are similar to exponentials, you can technically take this and put them all to the 1/2 power. And we're going to look at exponentials that are to the x power. Because arithmetic and geometric are going to come back, which is what we'll talk about next class. Okay, so what is an exponential? Where b is positive, a real number, and the argument x occurs as an exponent. So here is our basic parent exponential. Y is equal to, let me get my h and k in here. Minus h plus k. So notice another h and k up here. H and k mean the exact same thing. H is still going to be left or right. K is still going to be up or down. A is going to be stretch, compress, or flex x or y. The weird part is your h is just now behind the exponent. They are all going to move the exact same. First, we need to see what a basic exponential function is. So exponentials we generally use when we talk about money. So if you invest something into a bank account, you make a lot of money off of it, you're paying interest. Compound interest, yes. I think that might come back in this topic. And then a population. We use it a lot of times for population. So if population is increasing or population is decreasing, so the depth of something. Another instance of exponential functions that would be recent would be when COVID first started. It was actually an exponential function if we contracted COVID, okay, because it came and it spread very quickly. It was exponential. Okay, so do I have a basic thing in here that we can write on? I do. Beautiful. All right, let's do 2 to the x. So notice it's not 2 times x, it's 2 to the x power. So when I go to type them in, we do 2 caret symbol and then do our x, so that x is up in the power. Okay? This base, the 2, is not going to stretch it. This base tells me what shape it looks like. Okay? So the 2 will not change anything. He's not a stretch, he's not a compress. When I throw something in front of it, that's when it's going to stretch and compress it. So the base, that 2 that's attached to that exponent, is not going to change anything. He's going to be my OG. So we're going to look at 2 to the x, and we're going to graph them on all 4 pictures first, so we can get our OG done. So notice he does not cross this line. There is an asymptote right here. Okay. So let's look at our table. We're going to get closer and closer to 0. That's what that E means. It means we're getting closer to 0, but we do not cross 0. So let's get our first pretty one in here. 1. Okay, we have an asymptote. What's the next one? 1, 2, 2, 4. So right 1 up 2, 2, 1, 2, 3, 4. Do I have another pretty one I can fit in? Yeah, 3, 8. Right 3, up 8. So we're going to get big. We're going to go close to his asymptote, but not cross his asymptote. So if I do not shift my graph up or down any, the asymptote will always be at this line, which is this line, an x equals, oh guys, x equals or y equals if it's left or right. This line, if I make the equation of this dashed line, x equals or y equals line. You're doing the opposite of the axis of contrast. Okay, so this asymptote is at y equals 0. Please put arrows on it because they go on forever. Put arrows on them. Okay, so he is my m of x. Now I'm going to put a -1 in there. So if you have an 83 where you get the caret and you get counted, you might have to put parentheses. So if you are an 83 person, for the next one, you're going to have to do this, where you put them in parentheses. 84s, it should bump you up to put the exponent. I'm going to change your sign, just doing -1. Nervous, put parentheses. Okay, so 2 to the x -1. 2. Yep. 2 to the x -1. Anyone got any idea where shift is? Left, right, up, down? Shifted to the right. Okay, because the x value, the thing with the x, goes right. So this is going to be my right. That means this will go left. So I'm literally taking that U shape, I'm shifting it right. 1. So all those dots will technically move right 1. I'm going to put P of x on it. So anything with the x is still the opposite. Okay, which means my +4 will send it left 4. So all of those dots from my end are actually going to go left 4. For my term function, I want to let one negative right to my because notice it's more so on the left side of my side. Actual points on your table to look at more. Notice my first value I chose was -4. All right, so the next one, notice I changed the base to a 3. So we can change the base numbers to be anything, as long as it is not negative, because negative we won't get an x in it. Okay, so notice my base number is 3, so now my parent function is 3 to the x, and 3 changes where my starting point is. Okay, so type in 3 to the x, and then we're going to see, anybody got a guess as to subtracting 1 or adding 4, what it's going to do if this is on the outside with the k value? What direction the -1 or +4 is going to go? So on square roots, if it was on the outside, which directions? We just said left or right. This one's going to be an up and down. Anytime it's a k value, or if it sits on the outside, it's going to shift it up or down. So this one's going to send it down. This one's going to go up. So let's go ahead and get our parent function in. So I'm going to do 3 to the x. Also 0, 1. 1, 3. 9. Didn't move them up or down yet. Let me know if you guys don't understand something when I'm doing this, because right now I'm just assuming we can graph these on our table. So if you don't get something, holler at me. This time my asymptote should move with it. you do the, oh, you're doing minus 1. That one I just did 3 to the x. Oh, correct. Minus 1 that is outside. You have an 83, you need to end your parenthesis, after the x, and then do minus 1. So if you are an 83, well, no, you can probably do this. Well, you can do this. Or this. It should automatically lump the minus 1 out for all my 83s. Wait, say what? Yes. Because you shifted, it was at 0, so now my whole asymptote's going to go down -1. So if we look at the table, technically that's close to -1. They're not actually -1, but because it's so close, like I say -1. But we're not actually supposed to be crossing that -1 spot. So I'm going to go ahead and put, we're going to get asymptote crazy here. And now I'm going to graph my points. Let's find some good ones here. So 0, 0, 1, 2. 0, 2. That's getting close to that -1 line that is not crossing. I realize some of your tables might say -1 is not actually crossing. With arrows. Anybody got a guess as to what my asymptote is going to be for the next one? For this up 4. This one was at -1. What's asymptote going to be for the next one? Should be y equals 4. So this value right here always gives you that asymptote. Because it's my up or down. G all up 4. Stretches and compresses, and our reflection is left. The last thing, reflections left, and then when I change that base to be a number, small. 2 and 3. I think the next one I might use 4. All right, so go ahead and get your 4 to the x in, graph your OG. We're going to see what happens when I shove an a value in the front. So notice, now I actually have numbers that are in front 2 times this. 1/4 times this. That is what a stretch and compress looks like for exponentials. Normally you guys see the 4 and you take stretch 4. 4 is the base number. So get your 4 to the x graph in there. I'm going to get 2 out there. Unless you really want to okay, so I have my y equals 0. If I'm stretching and compressing, it should my asymptote because I did not shift it up or down. The only time your asymptote changes is is when I add or subtract something to the back end or shift it up and down. Okay, so go ahead and throw a 2 in front, do 2 times. Make sure you actually do a times sign or use parentheses. You can't do 2 or 4 because it's times for the x. It's going to stretch my points out, which are going to get probably massive. It did. So here, let me show you both at the same time. It's hard because I picked a base number that's so big. Okay, it goes from my red is my OG and my blue is my exponentials are a little bit hard to tell too. Okay, so is timesing by 2 going to stretch it or compress it? Stretch, which means my 1/4 will compress. Yeah, these ones are really hard to tell with the section. And then we got a reflection blank. So what I'm going to do, guys, is if you want to kind of do it on your own, you can. Otherwise, I'm going to try to get through this next one a little bit quicker here. Is everyone good with the stretch compress? Okay, so let's get, we already did 2 to the x before. So 0, 1, 2, 4. Remember what any negative on the outside is going to do with reflection? So the next one, negatives on the outside is going to reflect the x or the y. Negatives on the outside is going to reflect the x or the y. Across my x-axis, so this guy, so it'll be a mirror image across that. This should reflect the y-axis. So it'll be a mirror image across the y-axis. So that's what I'm going to kind of do and just mirror it. My reflect x. Mirror image of it across my y-axis. Just going to mirror my dots. And shift up or down. I didn't add or subtract anything to the back end. So the asymptote is still right over there. So these, all of these you guys should have seen in IM 9 and parts of IM 10. Just finished testing my kids on. That's like x-axis. Put your pencils down because we have 3 things left. Next one. You can't have a negative base because the negative base is going to kind of like bump your dots back and forth, in this case it's not an exponential. You can't have a base that's smaller than 1. So between 0 and 1. So all the bases I've done so far are 2, 3, and 4. You could have 2 to a million as a base. It just is going to look different. Okay, but they will also increase. So this is going to say, well, what happens if I have 1 half? So you can use 0.5. If you want to use the fraction 1 half, you have to use parentheses and say 1 divided by 2 and do it to the x power. So I want you guys to graph it and look at it and see what happens when I change that base to be a number less than 1, between 0 and 1. Okay, so if you want to use 0.5, you don't really need to use parentheses. You can. Otherwise, if you use 1 half, you have to put them into parentheses to say the 1 divided by 2 is together. To the x. You can compare it to 2 to the x. So what do you guys notice? What's the difference as to all the ones you've been doing to this one? Yeah. So is this one increasing or decreasing? Decreasing. All the other ones are increasing. So if you have a number between 0 and 1, your fed function is going to decrease or go downhill, which means this is generally losing. Yeah. Okay, so generally if a virus comes in, or a plague happens, right, and it's dying out. So anytime you have something between 0 and 1, it should decrease. Okay, so I guess I should use a B, not an X. So anytime that base is between 0 and 1. Okay, so if you want to go ahead and test 1/4, so you guys can see that it is going to be smaller, or use 0.25. It should be the exact same thing. Otherwise, use parentheses 1 divided by 4 parentheses the x. It should be decreasing or go downhill as well. It's just kind of what the bases look like when you change them to be a not so big number. Okay, so what does the k value do on the outside? Up or down? And this one, it means something else as well. Outside of up or down, anyone else remember what else the k value did? Asymptote. And it was always y equals. So if I shift the graph up or down, my asymptote goes from y equals 0 to whatever that y value I shifted it up or down to be. Okay, what's the h do? Left, right, opposite of what you think. Okay, we have our reflect y. Still up with the x. We have our stretch, our compress, and our reflect x-axis. This b is the base. It does not do anything other than tell you if it's increasing or decreasing.